Good afternoon. Myself, Dr. Ashutosh, and working in the geoinformatics department. In today's lecture, we will discuss about overview of spatial data quality. When we talk about quality, it refers like a certain characteristics, criteria, or standard. So, if passing this, if above this characteristics criteria, if any product or things are there, we always say it's of bad quality or good quality, and if it is below that characteristic or criteria, it is there. We say generally it is not of good quality. So in like take an example here. We are searching for a mobile or laptop. We generally go for the market and search for the mobile, and we see that it mobile should have some 8 GB RAM, should have some 128 GB storage capacity, camera should be there, and how much megapixel it is there, so front camera it should be there. So we are defining certain criterias, and if we are able to find out, and also we will look for the some price. So if we are the anything it is, we are getting the mobile phone which is coming into these criteria, and so we can always say we got some good quality things. And if similarly in the GIS, we are discussing about our data quality. In GIS, we talk about there are two types. As in my previous lectures, in this module, you might have learned about raster data and vector data. So in GIS, basically we are dealing about the raster data and the vector data. So we talk about these qualities. In vector data also we talk about spatial data quality, and there are type of spatial and the non-spatial data. So we talk about their quality. Okay, so like take an example. If you have to do some network analysis, and for that you need some road data, basically this road infrastructure data. So you get this data from the suppose 2 3 sources, or so how will you justify or will see that which set of data you should use for your particular application, which source is giving you the best quality data. Okay, so the things we will discuss. Similarly, another example, if we take we have a different sensors are there over the satellites. They are providing us the different categories of data, like some are very high resolutions data available, some may have a very low resolution, not good means moderate resolutions data available. So we need to see for a particular application, particular specific type of resolution we will be using. It is not like every is kind of data we can use for any application. Just like for particular application, a particular data will be definitely required. Like we have to do the urban study. Definitely we need some high resolution data, and maybe the good quality data, what we can say. And we have to do the suppose weather prediction analysis, weather analysis, which is observing the clouds. It may not be that much basically high resolution data required, we have to do the forestry analysis. So the whatever required for the urban studies, it may not be possible for may not be required for the other studies. So for a specific study, a specific kind of data may be required. So like quality we define in terms of person to person or object to object, we can say. We take an example, another example, like this table is there. So this is very well it's a smooth table, and very well it is designed, and this is basically for the what purpose? This is basically for the study purpose. So I am giving the lecture from here, and you are also having a similar tables in your front of you. So this is for the basically study purpose. Now if suppose 4 person come and use this table as a dining table, so what will happen? They will say it is not good for dining, basically. So for them the quality of this table is not good, and for me it is a very well, it's a very good. So it depends, the quality depends on the objective also, and the basically related to the different parameters. So all these things we are going to discuss in today's lecture. So these are the basically learning objectives of today's lecture. We will discuss about the data quality elements and quality and the fitness for its use basically. Now, at the end of this lecture, you should be able to explain the elements of the data quality and what is the importance of its data quality. So, what is quality? Quality refers to as good or useful things. The term is commonly used to indicate the superiority of a manufactured good, or at least to a high degree of craftsmanship or artistry. The meaning of quality depends on context in which it is applied. Just now I have taken an example. The meaning of quality depends on context in which it is applied. That means, like I talked about the table. So if this table is very well designed for the giving the lecture, and it is very smooth for the study purpose, but it is not meant for the dining purpose. So for the persons who are coming for a dining, using this table as a dining purpose may not be good. For them the quality of this table is not at all good, but for me it is a very good. Okay, so the quality depends on the context in which it is applied. Quality of data is more difficult to define. This is another important thing. Like unlike manufactured product, data do not have physical characteristics that allow quality to be easily assessed. Means like I talked about table, I talked about mobile phone. So these are the physical things. By the storage, by seeing and by touching this surface, and by knowing about the capacity of the mobile, means like a RAM or the storage capacity, so we will be able to know that's a it is of good quality or not. But data is a different thing. Here by seeing or by that, it's difficult to recognize that whether it is of good quality or not. So there are certain parameters, certain characteristics, certain modeling or mathematical aspects which we need to consider when we are going for to assess the quality of this data set. So unlike manufactured product, data do not have any physical characteristics that allow its quality to be easily assessed. So quality is thus a function of intangible properties such as accuracy, precision, completeness, and the consistency. So we talk about these aspects: accuracy, precision, completeness, whether data is complete or incomplete or over complete, and what is the consistency of this data. All these things we generally define, then only we can tell this is of good quality data. And apart along with this, as per the ISO standard, the definition is that the totality of characteristic of a product that bear on its ability to satisfy stated and implied needs. So we have to define the definition of basically these characteristics. We have to assess these characteristics, and based on that only we can tell about the quality of the data. So in general, if we talk about, quality should be assessed by the fitness for use. So how much that this data or any data it is basically fit for your intended application. In terms of that, we define the quality of data. So what is fitness for use? According to Vanner, he has given the definition, and as per that we define this fitness in the three steps. For the first thing, like does the data set contain the information which is required for your intended application? So first thing that what we have to see is the data set contain that particular information. Like you need to do the network analysis, so you need to see that's a you should have a network analysis you are performing for a particular city. So the all cities road should be there in that particular data. If it is not there or any part is missing, that is not a complete data. Similarly, you can see that the other data set like raster data set, you must see that's at what scale you want, what basically that resolution you want this data for your intended application. Okay, like your urban application, if you are doing, you need to perform, you need to have some high resolution data. So similarly, for your whatever your application you are going to do, you first need to see at whether the intended application for the information whatever it contains, it is intended for your application or it is out of beyond that. Okay, then second things what we are seeing here, what are the legal and financial constraint to access or particular use of the data. So what are the legal and the financial constraint, that is another thing. So there may be some data which is restricted, which is not open to the all, maybe the open citizen or all public or all country people, but it is maybe restricted to some specific agencies. So such type of data, if we use, then we have to take the permission, or for what purpose we are using this data, we need to tell the concerned agencies. First of all, it is getting the data of such data is very difficult also. So what are the legal constraints? Similarly, if you are using the such data, like you are using the shape file of any place or country or state, so you must see that it should not be like a distorted, it should not be like a maybe the some part is missing or some part is not available in particular data. Because if you see you use the such type of data, then it will be very difficult when the other person say it claims that it is not my country map, or some it is not, that part is not there, some legal issues can be there. Okay, so we need to very careful while using such type of data, that the information should be perfect, it should not be any missing information should not be there. Okay, and similarly the financial constraint, but when we talk about the financial constraint, it's always related to the money. So whether we are able to purchase, how much money it is required in that, what are the, whether we can buy or not. So this is also related to the application of data. Are the data are of sufficient quality for your application? Now first objective when we seen, then we talk about the intended application. So the information, the road information for a city, it should be there. Okay, now the second thing, the data are of sufficient quality. Third thing, so sufficient quality in the sense the roads you information you got for your application network analysis, but whether the roads are connected where it should be there, like one road is coming, there should not be any gap, so then only you can perform the network analysis. If the roads are not connected at a particular end, at the end, generally roads are connected at the both the ends. If you see, in case of only except the case where the road is having a dead end, when dead end is there, that time it will not be connected, otherwise generally roads are connected. So roads are connected. If you are getting the shape file, so if the roads are not connected in that, that is data quality is not good. So if you will perform the network analysis on such type of data, then what will happen? If you have to find that suppose shortest route from what point A to point, go to the hospital B, okay, point A to point B, then if the roads are not connected, then instead of following the path A, you may be following the path B, which, but the A path whatever the you were following, it would have been the shortest one, but because of the connection, the road was not connected, the you may miss the data, and you may miss the basically the path, and then you will follow the another path. Okay, so we have to see whether the data are of sufficient quality for our application. If we are able to follow all these steps, that means data is data is fit for our intended application. Now the question is another, why we have to do the spatial data quality. So it is an important thing. For centuries, cartographers, geographers, surveyors, geodesists have been involved in the collection and the storage, analysis and visualization of spatial data sets. they have also been studying spatial data quality. So earlier time only was the like a surveyor, they used to go and they used to do the survey, and similarly cartographer, they used to make the maps and maybe the paper map, whatever it is there, and based on that only there's whatever possible things that they used to do, analyze the things, and they used to do the spatial data, analyze the spatial data quality. But now, since 1980, concerns about spatial data quality have increased as a result of a two developments. One, it's the emergence of the geographical information system tools in 1960s, and the second, from the 1970 onwards, a strong increase of available spatial data from the satellite. So here I will just tell one thing. When you have maybe the limited information, that time it is sufficient. Like earlier, when 1960 we go, that time how many satellites were there? 1960s, 70s, very few satellites were available. We were getting the limited image, even a aircraft image, putting the camera on the aircraft, we used to have image. So that time limited image, by seeing from the sky, that was a big thing. Okay, we are able to see the our land from the sky. Okay, so that was the itself big thing. So and that time we will say, okay, it is good, at least we got some picture from but what happens when the number of data the satellites increases, we used to get lot of images. Nowadays lot of satellites are there from different countries, so we have a lot of satellite. Then when we have a number of things, then what we will say, we will say about, discuss about the quality. Okay, it is something like just you have one mobile phone which is very old. When that time, go back to the 20 years back, if you remember, there was not much mobile phone were there, even a one small mobile phone when the case came just only for talking purpose. That time this was a big thing. But now today, if we see after 20 years, then we are having a lot of application, we are doing a lot of application using the mobile itself. So we are selecting that which one is the good. So when you have a more data set, more spatial data set, definitely you need to go for the we have to go for the good quality. We can always assess the means we can always assess the quality of this data set, and we can utilize the data whatever it is fit for our intended applications. Okay, and then emergence also 1960, this GIS emergence has come. So GIS, we know about the we are doing storing the data, we are analyzing data, visualization purpose, we are using this GIS. So in that this is a part of that quality, spatial data quality also is a part of GIS, and we have to study it. Okay, so why spatial data quality? Because this is the availability today, more availability it is there, and exchange is also there. Now lot of products we are generating, and then we are disseminating to the other users. Okay, like today we are providing the images, and then other ministries, departments, they will be using this data set, and then based on that they are taking the decisions. So it's playing a very important role. If we are providing a good data, good quality data to them, then definitely information to them, then this will be used for the basically decision makings. Okay, and then growing group of user when less aware of spatial data quality, this is another thing. So when you push on the put up the information, suppose on the decision maker, so maybe they may not be aware about the very well about the spatial data quality, but they are relying on your information. So when you are doing analysis, and then after that only you are sending, then they will totally rely on your information only. And so that's a, and the people other side, if you see, the like a lot of people are nowadays using, they are maybe the you will be using the support just on an image, they are not much worried working or aware about the basically the spatial data quality. So that's why this has become very important to train them that spatial data quality is an important parameter, or basically the criteria. So we have to assess first the quality, then only this pass we should the information to the concerned users, decision makers, or whosoever it is there. Okay, then GIS software can process data irrespective of its quality. So what happens, whatever the GIS software presently it is available, it is not like that you will put the input, you will do the some analysis, and it will provide you some output. But it is not like you are putting that and they are telling you that, so basically it is of good quality data, or it may not be the of good quality data. Okay, so they are just processing the things according to your instructions, according to whatever analysis you are doing. So hardly any tool for is handling the spatial data quality. So that is why it has to be assessed, maybe in your separately, what we can say, apart from this software, by seeing, by analyzing, by visualizing, by doing the mathematical things and equations, using modeling. So all these things are there. And then distance between those who use the spatial data and those who are the best informed by spatial data quality. This is also one of the reason why this quality assessment is important, because the people, those who are much aware about the spatial data quality, they may not be giving the output to the concerned users, but those agencies who are working for the users, they may not be aware about the quality. So both person has to be bring at the same platform. We have to train that quality is also an important parameter, and you have to work accordingly, and then this gap will be reduced, and then finally the output product or the concern, when we will put the users to this product, it will be more useful, and more precise it will be there. And similarly, producers and the users perspective, if we see, these trends have contributed to a reappraisal of the responsibilities of producers and consumer of data quality. Responsibility for assessing whether a dataset meets the need of a particular application has therefore shifted to consumer, who is in a position to make such an assessment. This referred to as determining fitness for use. So from the data producer, there are certain points for the data producer as well as the data users as well. So for the data producer, he need to see what is the specification of the data set. He has to provide this information also to a concerned user. What is the specification, in which projection system you are giving, what is your resolution, all the relevant information of the particular data set he has to give to the concerned user. They may have to meet the statutory obligations. So if any obligations is there, any constraint is there, they have to tell about this data to the concerned users. And is the quality reported? So whatever the data is going to produce to the users, whether the quality in that data is reported, whether it is of useful for the basically concerned user. Maybe your data, suppose whatever you are producing, it may be the 80% is accurate, or 90% is accurate. So whether you are telling that percentage to the concerned user, so that's why you must tell that what is your quality of the data. Okay, then data user's perspective, he has to see, needs to know if the data are of sufficient quality for this particular application. Whatever projection system or whatever he say, that's basically resolution data or the scale data, whatever it is intended for their particular application, then whether he is getting from the producer or not. Okay, before giving, before doing any financial constraint, limitation, maybe agreement, we need to see they are going to get, what we are going to get, what they are going to give. And they need to be able to interpret the producer's quality report in this context. So they have to read the quality report whatever provided by the producer, and they have to study, and based on that they can see whether the data is of good quality or not. But he should have the user should have able to should understand whether it is of good quality data or not, what are the quality parameters. So he should be able to understand, based on that only he can tell that whatever the producers it is giving the data is of good quality or not. This may still not give the information whatever they need, so we have to assess the quality ourselves as well. So in GIS, it is the basically the model. What we are doing, it's a real world database is the basically model of real world or computer representation of the real world. So in real world, whatever the problems are there, we are forming these problems, and then basically what we are doing, we are collecting data collection we are doing. Based on that, to form what are the like we are going for the GPS survey, we are getting the data from the satellite imagery, photogrammetry, and the any other sources like some old maps also can be used. So from that we are doing the data collection. Then this data collection, it will go as a maybe raw data as a, and then for the as a input. So for input, like you are using this data set, and you are basically what you are doing in the editing you are doing, and then creating shape files, and that data you are doing. Then finally all these data will go for the analysis, and different models will be put inside, model will be used for the analyze purpose. So data model means it's like mathematical equations, a modeling will be there. So where we will be using the different equations or modeling, whatever we are doing, analysis, or we can say the simply the analysis we are doing using this data. And finally visualization purpose, we are giving this data visualization we are doing, we are representing a, we are making a good maps using that, and then the information will be sent to the particular department or agencies. Okay, now what will happen if in the concept real, when the real world problem we are conceptualizing, that time itself, suppose some issue comes, then the next stage, data collection. So data collection itself, maybe the giving the certain error can come, like you are using the GPS devices. It's just an example, you are using the GPS devices for the data collection, and you went in the field, you are going into the field for the data collection. Now if you are standing at a particular maybe the in open area, you may get the good signal and the good coordinates you are going giving getting. But when you are standing at a place where nearby buildings are there, so signals will be definitely, when it is coming to buildings, definitely it will be affected. So whatever the maybe we are getting the position, it may not be possible that it is giving the accurate, maybe that the multipath error will be there, we have to reduce it, that is another thing. But what I am telling, if we are considering such type of data, definitely our accuracy will be reduced. So if accuracy is reduced, that means we are giving, we are entering into, we are giving input some inaccuracy we are entering in this model. Okay, similarly instead of maybe the other data set also will be having a similar type of similar or different type of issues. Okay, so input itself, concept itself, some error was there, maybe something that maybe it should be there concept wise also, it should, the area whatever we have selected, it should not be, or it a b type of area selection should be there, something like that. So a, that's a concept wise, then data input wise, that's another thing. And then when it goes to the basically like third thing, that's a input wise, means like editing. So if you are editing using the old maps, then old maps, what editing means, like using the map, you are taking, making the shape files kind of things. Okay, so you are making the basically like polygons, you are editing. Okay, so background it will be there, that image will be there, and then based on that you are editing. Now what the polygons when you are making, then what will happen, it may be the boundary is must be shared. Okay, it may be should have a common boundary, but definitely maybe some, because of your editing handling, so what will happen, some gap occurs. But in reality, if you go on the ground, between two field, is there any gap? There is no gap at all. Okay, two fields are there, two land parcels are there, they are meeting, they are not at all gap is there. But when you are editing in this, definitely you are doing some mistake, and then definitely because of that some error is coming. Okay, this is the third thing, it is coming input type. Now we consider like a model. So model also will maybe having a certain errors. How? If you select A type model, may give the less result, but B type model may give the different result. How? Just take an example here. If you have suppose 10 radius, okay, 10 radius, and 10 radius measurements. Okay, you have measured certain thing and 10 radius measurements. Now if I tell you, just tell me the area of the circle. Okay, so what will happen, what you will do, average area of the circle. What you will do, either you will just take the average of all 10 radius, and then take the then pi r square. So the average radius you will put it into a place of r, then pi r square, you will find out the area. You will tell me, so this is the average area. But the other people, what they will do, they will find the area of the for each radius, like for r1 it is a pi r1 square, for r2 pi r2 square, pi r3 pi r3 square, and the similar, so on. Now they, what they will do, they got the 10 areas, and after that 10 areas they have just done the average. Okay, now what will happen, whether both the area this also average area, this also average area, whether both the area are same, no, it may not be, because it may the differences will be there, the modeling process is there. Okay, so when you are using the modeling process, in a different modeling process you will use, you may get the similar different result as well. Okay, though it may be minor, it may be major also, but the model also plays an important role. The modeling, because of the modeling process, you may get the two different areas. So similarly in the GIS, if you use the different model, you may get the different results. Okay, now in at each step we get the we have inserted some errors. Okay, now finally the output. So error, when you are finally when your output it is coming, you are displaying it, and at the time also we may lose some information, and we may represent something else. So from conceptualization to the output of data, everywhere there is a chance of an inputting an error. If you are able to handle it, then your output will be correct. Otherwise it will be multiplied and different labels, and your output definitely, maybe it's a maybe minor you are adding, but at the end of that you will be having a some maybe big also, or maybe minor also, but definitely error will be there in that, which you can avoid in the sense by selection of the correct parameter, by selection of correct basically place where you can collect the GPS data without any errors. This you can handle it very well. You can when we talk about the inputting, the data editing, so you can, when you digitize the data, then there should not be any gap. You should follow all the topological rules, so there should not be any maybe having any issues. Okay, so that way you can basically avoid the things by selecting a correct model for their application. So this you can do, and similarly for the output, you can place it at a particular place, so they should not be having maybe without any error. So you can try, and you can just maybe what we can say, we can minimize this error. Okay, GIS data is of good use, as for us it is of good quality if or error free, and data is evaluated based on certain parameter, like again I will say its fitness for use. Take an example of the basically quality things. So if you see, there is a one I was searching, like Volkswagen Dehradun, some place. Okay, today it is corrected, but this when it was searched, that location was showing somewhere here. Here if you see the red one, but exact location was here somewhere, Volkswagen Dehradun. Okay, now this and this almost, if you see, roughly around 100 meter 150 meter, the difference was there. Now whether it is of good quality, whether the point should be there at the particular place, or it should be far away from that place. So for certain application this may be useful, for certain application, in the sense, if I am going, I just have to go to that particular place. Okay, I will drive my car, and even a 100 minutes 100 meters before I will stop, I will check it, there is no showroom nearby, and then I will go forward, and then what I will do, I will ask, maybe I will apply my mind, I will see by visualization, using my eyes, I will see here, slowly I will drive the car, and at least nearby area I will get this place. So for me it is it is fine. Okay, anyway, it is not good, but it is, I'm reaching at that place. But in case of suppose any emergency comes, any fire happens, any ambulance comes, okay, whether they will go and they will reach at that particular place 100 meters before or 250 meters before, they have to look for where it is this, where it is this, whether it should be, no, they have to basically, it has to be very very precise. They need a precise information, then only they can reach at that particular place. Okay, this is a on road, we can understand very well, but when we city where it is a congested, it is there, small roads are there, how they don't have a chance, they don't take a chance. Suppose they are going in this way and the road is blocked already, okay, they have to go by the other road. So like that, the correct map information should be there. The quality should be better. But again, as in beginning I say, that's a quality may be depending on the as per our requirement. So for me this map may be okay, but for other people it definitely it is not going to be okay, because they need a precise information. Okay, similarly, the other things, if you see, mm, when we search for a any particular location, okay, so whether that location is a point, line or polygon, what answer we are getting? Generally if you see that, it will show that the location is a, like a point. So I am getting a information like a point, that place, but that particular may be the polygon. Again this depends on the basically scale size, at what scale we are seeing. So this all information basically we need to consider when we are searching for things, we are making the maps, what we are basically using in our data set, what we are using in what data set we are using in our applications. Okay, take another example. Suppose we need to measure the area of a parcel. Okay, it's around 200 square meter. It is there, and you have been given a two sets basically. One is a two sources, what we can say. That's one is a using the GPS. You go onto the ground and then you measure the points and then find out the area how much it is there. Okay, it may be close to the 200 square meter, plus minus something will be there. And using the satellite imagery, so here we need to consider the different parameters, like we need to see the scale, we need to see the basically what we can say, whether how much line, when you have digitized it, how much, what are the pixels it has been covered, okay, what are the pixel size. So this all the things we need to we have to see, and then accordingly we can define that this is the area of the land. And by using the GPS we need to see how much basically decimal terms we are considering. It is not like generally what is happening, we are taking the data up to the 2 decimal points, okay, but whether it is correct, GPS devices, if you take the handheld GPS devices which are very much accurate, maybe giving the up to 10 decimal, 51 decimal places. So it's up to 2 decimal. If you are truncating, that means you are introducing some error inside that also. Okay, so there are the quality wise, if we see in case of Google Map, in case of pass maybe the area, different assessment parameter we need to consider. We have to see their characteristics, parameters, and then only we can say this is of the basically good quality. Error chances are there, their GPS also it will be there, by mishandling also it can be there, by truncation also it can be there. Similarly in the satellite imagery also it can be there, at what resolution you are using, what is your pixel size. Okay, so we need to avoid for to get the good data quality. Take another example. If it's uh, a very common thing, if I say, okay, this let us consider the according to the land department records, that's the area of land, area of a small piece of land, the parcel is suppose 10.044 hectare it is there. So the parcel is sold, and then the new owner measures the area by moving around the parcel with a global positioning system device, and according to which the area is 9.890 hectare, which is 0.154 hectare less than the according to the land record. Now one person is having a certain land, the area is around 10.044 hectare. that person sells that land to the another person, and that person says what he did. Before taking, he should get the, even after taking, he should get some confirmation also, na. So what he did, he just took the GPS device. He told GPS device is very accurate, so he just took the GPS device, and then he just moved along the boundary of that particular parcel. Now he found that the area is around 9.890 hectare, which is less than 0.154. Now what he should say, he went to the again that seller. He told that I have paid you as per the price, like 1 lakh rupees per hectare. I have paid you this much amount, and your area is basically less than 0.154 hectare. So what you should do, you should return to me. That's a 15,000, some amount you have to return to me. So he told, no, 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 you are telling not correctly. You can see this land record. This is the registration from the registration department, and this area cannot be less. This is at this much area, whatever I have sold you. But he told that person, buyer, you are telling wrong, because GPS device cannot be what we can say incorrect. Okay, so GPS is giving the precise information. Now where is the problem? If you see, think that you will say maybe the land record person maybe not telling correctly. He may be that, because GPS cannot be wrong. Okay, but here the problem is that how he has measured the things. He whether now he whether the he has moved along the boundary. He has told clearly whether the boundary is clear or there is some fuzziness is there. Maybe there is the place where the boundaries are not clear. Maybe the place. Okay, so here it whether this type of situation occurs, or second thing is there between the like a bound near the boundary, or if you see the an agricultural field, there is a near side by side that ditch will be there for basically the water, or flowing, or maybe moving, what we can say. So there is some side is there. Okay, generally maybe it depends from both the person's field, if side by side it is there. But if even if you it is not there, that maybe person can make in there for giving the watering, like that they can make it. Okay, so whether he has considered only the inner edge of that, or whether he has considered inside that ditch also, that also he has considered. So that's what the that person says, the seller says. So vendor then argues that the difference could be further be explained by misinterpretation of parcel boundary explain definition, or due to inherent fuzziness of the boundary. So because of that, the error can be there. So your GPS is correct, and my things are also correct as per the land record, but the problem is to about the misinterpretation. So these are the issues which we have to, now such person if he goes to the maybe for the higher authorities or administration for the clarification, that administration also may not be having that much idea. So what they will tell you, what they will find out some maybe the GIS experts only, and their GIS expert, GNSS expert, GPS expert, they will go to the on the ground, and they will see the situation and along that, and then they will practical situation as per that they will tell okay, this is the basically actual situation, there is no difference, or if any difference is there, they will let you know. Okay, so that's why your role is as a GIS expert, with knowing the spatial data quality is very much important. So did the buyer move along the inner edge or the center of the ditch that's around the parcel? So what these examples tell us, basically firstly that the spatial data quality is an issue in many decision analysis. Secondly, the example shows the importance of the basically definition of spatial data quality. And thirdly, the example identifies a need or information on the spatial data quality. And finally, the example shows that the spatial data quality is not an issue for the scientist only. Spatial data are used in the decision making, and spatial data quality has implications for the decision making analysis. Okay, so it's very much useful. If you will tell to the administration, then only they will trust on you only. So you will tell that both area is are same, whether he has as per the land record and whatever he has made as the GPS. So where he is measuring, it matters a lot. Now there are the the uncertainty in this database. So there could be these stages of uncertainty, three stages of uncertainty. It may be due to the conception, concept wise, measurement and representation, and for the because of the at the analysis part. So when we talk about the concepts, and there are the two things, vagueness and ambiguity. So vagueness comes due to the poor definitions, where where of the basically the definitions are not clear. Like, when does the grassland stops and forest begin? So clear boundary definition, suppose it is not there. We are not sure that the boundary is crisp or well defined. So that means this vagueness things will come. Now, ambiguity, if we see confusion about the representation of the geographic phenomena, it is like a building. We have to represent it by point or polygon. So that again it matters what scale we are seeing or representing, but this is sometimes it makes a confusion. The people you use the simply whatever scale they are using, and they just put the dot only. Okay, we can represent it by building. Suppose any if you see the maps, this is a police station. So scale it matters, where police station cannot be like a point kind of things. Okay, how should geographic feature be represented? Just now I have given the examples. What attributes should be ascribed to a feature? So what are the associated attributes it is there? So because of that, this ambiguity things can come. Then measurement and representation wise, if you see, we talk about the resolution, at what resolution we are using the maps, then density of the observations, how many data points we are collecting for our application purpose, then fuzzy natural boundaries, with fuzziness we have to consider, and then we are seeing the georeferencing. At georeferencing, which map projections we are using, all these things we have to see. Then digitizing errors will be there. When we are digitizing, then as I told you, the overlap thing should not be there, and the boundaries should clearly meet. There should not be having any gaps. This kind of things we will see. And we are having also always the instrumental limitations. Okay, so some instruments, that's why we need to calibrate it again and again, and we need to, it's not like the instrument once we have used, and we are seeing after 1 year that same instrument we can take it into the field, but we have to calibrate it, we have to do the calibration properly, and so that's why it can give you the accurate result. It will continue giving. Okay, and these are also having a certain limitations. Okay, with the GPS devices there, is giving you up to 10 decimal places data. Okay, but if you want 15 decimal, 20 decimal, 100 decimal places, may not be possible. Okay, so this is not there, but we can consider up to the 10 decimal also, it is sufficient data. But instrumental, that also can give you certain results, but still maybe they are also having a certain limitations. Analysis wise, if you see error and approximation in model, numerical error in the computer also it can be there, as I discussed, and error propagation also. When we are propagation means like in initial time itself it will be there modeling error, and then propagate error will be propagated, okay, through the modeling process. When we talk about the data quality parameters, we talk about different what we can say terms in which we are discussing the data quality, like lineage. These are the basically a few points we have given the earlier, and these are arises at different timings. Like first somebody has decided that so 5 points, then another next step it was divided as given the 7 points, then further 9 points, like that it was there. So it has evolved in the during the time period. Okay, so first is the lineage, then positional accuracy, then attribute accuracy, logical consistency, and then completeness, temporal usage, and meta quality, and the resolutions. So in on these points basically we are considering the data quality. Position wise, if you see that we are talking about like accuracy, bias, and the precision. So what is the bias? It is a basically systematic difference between the observed value and the true value. And precision, the spread of repeated data around their average value. And accuracy is the basically average error, the spread of the data around the true value minus composite of bias and the precision. So precision, we will see with this figure very clearly. Here you can see the four images or pictures are there. Okay, so let us talk about the this point, the red point. Red is the basically the cross section of you are seeing in this picture. It is a basically true value. Okay, and red value is the basically mean value of all the data points. Okay, so now if you see, the red value is totally coming exactly coming as the on the basically this cross section, where cross here indicates the true value. So cross value it is coming, and the dots are basically the black dots are the basically individual data values are there. So D, if you see the D image, it is a when exactly there is no difference, there is no difference, it is exactly it is overlapping the true value, the red value. So red dot, so that is the basically precise, that's the basically having a what we can say, no bias, this is a unbiased. Okay, and if you see the black dots, precision is basically how the data is following. Just now I told you that one previous slide, the spread of repeated data around their average value. So repeated data, how it is following. So you will take the observation, okay, using the GPS device. So 1 point is coming, 2 points is coming, 3 points is coming, 4 points are coming. So these number of points will come, how one is close to the other one. It should not be like a one is having a more deviation with the previous one. So one is coming closer to this one, this two second is coming closer to the third one, third is also closer to the third one. So it is more precise. Okay. So the black dot, if you see, these are very closely it is following. So that means it is a more precise and it is unbiased. So true value, if you take the mean, if you are comparing with this true value, there is no difference. It is exactly falling on the true value. So it is unbiased. Okay, there is no bias. True value minus just now the application I told you, systematic difference between the observed value and the true value. So there is no difference. Okay, and when these both are there, we can say it is an accurate. It is an accurate measurements. Okay, precise and unbiased. Now take the another one. In the second case, the black dots are here and the red dot is the average. Now if you see, the black dots are closely following to each other, so they are more precise. Okay, but their average, if you see the basically where with the red dot, if this is having a more difference with this crosshair, so what is happening, this is having a more deviation, it is having a no bias is there. Okay, it is precise but it is bias it is there. Okay, it is precise, okay, but bias is there, so it is not much accurate, it is an inaccurate kind of things will be there. Then take the another example, that is a. Here the points are little bit spreaded, it is not like a more precise closely coming, but still it is a spreaded. And if you see the red dot, the average, it is a closely matching with the basically the point where the true value is there. So we will say it is a moderately precise, it's not precise, it's a moderately precise and slightly biased. Okay, it is a kind of slightly biased, little bit bias is there, it is not exactly falling on the true value, and it's a moderately accurate we can say. And the last thing we can say, that's a C figure, if we see the black dots, it's a spread here and there. Okay, but their average is exactly following on the true value. It is some kind of things, one value you take 10, another value you take minus 10. So minus 10 plus 10, it will be 0. So it is looking like there is no bias here, no bias, but the points are not precise. Okay, so what we will say, this type of things also, it is having a unbiased but imprecise, it is not precise information. And then accurate, this is a inaccurate things will be there. Okay, that way we can define a lot of cases, we can make it and we can study. When we talk about the true value, it is like a reference data set. Okay, so reference data set is very very much important. It is not like a one time measurement and we have taken as a reference for the future. Reference data set always has gone through the rigorous procedure, then only we define that particular data set as a reference data set. So in order to calculate error, bias and accuracy, we need to define the truth in the context in of our data set, reference data set. The data what we are using some abstraction of the real bird that have gone through various transformation and processing steps. So it has gone through the various transformation and the processing step. So okay. Positional accuracy, closeness of location information to a true value, basically, and comparison when we do, then it should be there with the good quality data set. Okay, so we can have a like points any on we are seeing on the image, then we can always compare with the GPS data set, which we can go onto the ground and take the GPS coordinates points, and then only we can compare it. Okay. So the another thing is that the attribute accuracy, it is the closeness of attribute values to their true value, whatever the associated attributes are there, we are talking about that. Accuracy assessment is done by the polygon overlay. We can overlay the whatever you have created, and the reference value it is there, you can always overlay and then see how much difference it is there, and by doing the field survey as well on the independent samples. And accuracy of labeling for nominal or categorical data, we are defining by type, like type of land covers, type of roads, or kind of things. Nominal data or categorical data we can define like this. And for the accuracy of the numerical data, we always talk about the mean, bias, standard deviation, mode, precision. Okay, these are all the things we discuss in that. Then temporal accuracy is very very much also an important. So suppose you have to do the like a weather prediction kind of analysis, so you need to have some half an hourly images or one images, so data should be there temporally, it should be consistency should be there. Okay, so temporal accuracy of the spatial data refers to difference in the values of object location at the two different timings. So how much difference basically it is there. So consistency, when you are getting the images, then only you can be able to see the differences. So accuracy and precision of the time measurement, temporal consistency, temporal validity, boundaries of the parcel remain fixed over period of time. Whatever the analysis area boundaries whatever we are making, it should be fixed over a time, then only we can do the comparison, and then only we will be able to know how much changes are occurring. Okay, the completeness is also an important thing. Sometimes we are buying the data sets, and if you see the data is incomplete. Okay, so that is the another part that we have to see. Data is incomplete, and sometimes data is over complete. Excess data also can come. In both cases, we have to avoid this type of data set. We have to fix the data set, and then we have to do our analysis. So over less completion data set, then we call it as an error of omission, and then excess data it is there, then it is a or error of commission. So both places that be considered as a error basically. Okay, then logical consistency is the basically degree where we have to do the some logical rules kind of things, and the relationships, like conceptual consistency, absence of any contradiction, it should not be there. Like roads are going and buildings are there, so your road is overlapping over the buildings, and then it is going. Road is going and nearby some canal or river is there, it is overlapping, then it is going. Oh, no, it is not like that. There should be a proper bridge if you are crossing the basically river. So it should not be overlap over the building also, it should not overlap. So absence of any contradiction, it should not be there. Then domain we are defining in the domain consistency. If you are dividing a class like 1 2 3 4 5, then 6 should not come. Okay, if you have divided up to 5, it should be 5, it should not be the 6 should not be there. Format wise, if you want to compare or just merge the data with the other data sets, so both the format should be compatible, so then only it can be merged, otherwise it may not be there. Topology, Topology also an important things, like two polygons are there. It should, when you are the inside ground, if you see there are the two fields, two agricultural fields, both are meeting, but there is no gap. But when you are digitizing it, you are creating a gap. So this should not be there. This should be there. The gap should not occur between the both the parcels or both the land area. Lineage is a basically history of the data. Those who are providing that the history, how the data is formed, from what are the procedure it has been adopted to particular data. So it is all about, it is necessary to tell that. So basically it's a history of the data set, what we can say, the data sources, process steps. Lineage affect the other aspects of the data. Okay, so data, if linear is not given, then it is not possible to see the fitness, whether it is our for fit for our application or not. So we need to consider this point also. Okay, lineage. We talk about the, okay, that's just an example, we can take it some certain to show you that's how the basically errors are there. Vector maps, if you just to do the, you are doing the analysis, so sometimes you need to basically do the basically rasterization of or vectorization kind of things you have to do the. So vector map is in the form of polyline only, but raster in the form of the basically, you know, that's in grids and pixels. So boundary of the polygon will be converted into the zigzag form when you are doing the rasterize. So whether it is a, it is not a, like a smooth boundary, it will be in the maybe the zigzag form, it will be different. Okay, so this may lead to, when you estimate the area, then this may lead to the different area length of the geographic phenomena. So it will be errors can occur because of that. So if you have digitized land cover classes in polygon area, boundaries and well separated, but while converting to the raster, zigzag boundary will move into the other classes also. This is also possible by converting the raster. It may possible, that's it may belong to the other classes as well. So while doing the conversion from vector to raster, we must have or you should have defined the cell size at least less than the size of the smallest feature. Error associated with the digitizations, like one road network, it is there, it's looking smooth. When you are digitizing, so you need a number of points, number of what we can say vertices, so digitize it, which maybe practically may not be possible to fix that many digitization. So because of that, okay, smoothness will come, but actually little bit maybe the points will be seen looking like, no, not that much smoothness we can expect. Okay, so that error it can be there. And similarly, when we are overlaying on the two maps, then definitely quality of the depending on the whatever the map you have digitized it, depending on that quality, it may exactly match or maybe showing some errors also. Okay, so finally we summarize all the things and just to about this quality. Any poor quality raw data leads to the poor quality end product. Required quality of data depends upon the use of the data set, as making studies or making a conception does not need highly accurate data, but for navigation purpose highly accurate data may be required. So in nutshell, if I say summary, that data quality is an very much important, though we are not aware. So what we do, we are generally neglecting this part, and we are just doing our GIS analysis and producing some results. This generally if we are doing, that means we are introducing error and we are not aware about that. So we must focus on about this data quality issue. Even first conception is itself, concept wise itself, input wise, and then data creation itself, and then a modeling wise, which model we have to use, then finally output time. So at the every process, at every time, at every steps, I will say, then we have to consider this data quality issue. If you consider this, definitely your error will be less, and then when you propagate it, propagation error also will be less. But you introduce error at input time itself, it will leads to the error, propagation of error will be propagated, and at the last it may be possible it's a big error will be there. Okay, so try to minimize these errors and take all these points. So considering these points, definitely your error will be less. Okay, so thank you very much for joining this So, we learned about the spatial data quality in this particular lecture, and now the questions we can take. I can see one question here. Does the data set contain the required for the intended application? So, for data set, whatever we are using, basically it must have the metadata on the when it was generated, when what is the basically projection system of this data, what is the resolution, and when we are as a user we are buying this data or we are using this data, then definitely we should look for that what are the qualities of this data set, what are the parameters, when it was generated, what is the projection system, what is the solution or resolution of this data set, whether this is the whatever the resolution they are giving, and then whether it can be integrated in our application or not, whether it is like suppose data set is 30-meter resolution it is available, so whether we can utilize for intended application or it may not be there. So that way basically we need to see the data set specifications, and then we have to use for our desired applications. So can we integrate AI to get good quality and error-free data through GIS? Definitely now AI is entering in all field. So definitely try to club this AI with the basically possible removal of the data. So what we can understand like how what are the basically possible sources of the data sets where it can be there. So some of the places it may work, but some of the places when like data set required for your application is 5 meter, but the data set is available at 30 meter. So that way we need to find the data set source itself that 5 meter data should be there. So that way it will be we need the basically the exact data set, and the AI will be helping when like suppose any statistical parameters are there or so kind of error we need to find out. So that way it can help, and we can program, we can do the we can find out this one errors. But when we talk about a particular type of data set, like I need a 5 meter resolution, then we need a 5 meter resolution only for our intended application. Okay. So okay, I cannot see more questions here. So thank you very much. You can, if you have a further queries, then definitely you can mail us, and we will reply accordingly. Thank you. Thank you for joining this session.